Hello, uh, I'm Alex,
I'm Petros.
and we're building a project. Uh, and we're building a project with AI for a robot, and which is open source. The project aims to let users create robots easily, and they, it's for users to create their robots easily, and both in the server side and in the client side. Using artificial intelligence for the actions of the robot, such as ChatGPT and computer vision for object detection, etc.
Okay, I'm Petros again. I'm the engineer of the robot of this project. We're based in Greece, our company, our project. And so I work in this project like 2 weeks in my free time. And today we'll produce you our idea and give us some feedback.
Here is a net presentation of the robot. This is the hand of the robot.
Some on the stage, obviously. Some moves. Okay. We don't have very good motors for now. But if the project continue, we'll change all this. So the robot will be functional. This is the wheels of the robot. It's a test. It moves with 4 DC motors and Arduino. And I connect Arduino with a LiPo battery and a speed controller. So I can control the speed of the wheels. If you want, I can provide you the parts. I have the wheels. The body is just a case, a plastic case for now. Now I'm working on the body of the robot, just for the wheels for now. Just this. I put on the Raspberry. With Raspberry, I can control the wheels from Raspberry, Arduino, and Arduino gives them move to the wheels. And today I put some sensors on the Raspberry. The sensor, I have 4 sensors. I have a proximity sensor to locate the objects in front of the robot, a light sensor to understand when it's morning or night, a quality air sensor, and accelerometer sensor. So you can look or to understand the speed and the speed of the robot. This is all about. The introduction is too simple for the sensors. Raspberry is very easy to work with the sensors. All the sensors have 4 cables. Just your volts, your grounded, and the 2 cables with informations can communicate with the Raspberry. This is all about for the wheels of the robot. The motors is DC motors. Easy to connect. Just 2 cables, you can connect with the battery and that's it. You have move on your robot or what else you're building. About the hand, the hand is a kit for Raspberry. I can provide you where to buy it. It's cheap. With the kit of the robot arm, you have a servo driver hat you can connect on the Raspberry, and the motors of the hand on this hat. It's very simple to build something like this. Okay. This project will be open source. We will provide you a tutorial about how you can build it, the parts you have to buy, and where to find these parts. We also include the use cases and how you use it for different ways. So that's
While the server and the cloud code will be all hosted on GitHub. Right now, we're using the the Arduino CLI to connect it with the Raspberry, so we can send the commands to the motor. And the server is connected with the client using TCP sockets to send the images from the cameras in live connection. The service handling all the hard work like image detection, the request to ChatGPT, etc. And the client is built in a way to accept commands through text, which will be generated by the ChatGPT, and like move forward, move backwards, etc. Here is an example prompt that we will be using. As input, there will be the location, the objects around the bot and in front of the bot, and then the actions that it can do. And finally, the task. For example, if it is in a room that there is a window, a chair, a desk, and the walls, and if the robot wants to go towards the window, it will generate something like this. And these commands will then be fed to the Arduino. So it will move towards that. Same thing will be will be happening for the voice. Right now it's using Whisper, and in order to get the input from the Raspberry, and then it will be sent to ChatGPT in order to create a response. And finally, the response will be translated from text to speech and sent back to the to Raspberry and played through their speakers. So the user will be able to talk with the bot. And everything is built using the newest ChatGPT, so it can have the chat history, etc. of the agent. For the for the object detection, we're using OpenCV and YOLO version 8. Right now we're using a pre-trained model from YOLO, which can detect in real time objects in around 50 to 100 FPS. And then if there is a sign or something similar related, then it will be sent to EasySCR in order to detect the result, to detect the text from the image. what is more, we're building more functions for the bot to rate the current image of the bot that is seeing to be fed in ChatGPT as well, in case the user is asking uh, something about what the bot is seeing right now. These are all the functionalities that they are built right now. We are aiming to add more things in the future, like map generation and stereo vision to the bot to be able to understand the location around it. And also with the air quality detector, we want to be able to get the quality of the air in real time from the bot. And to get in real time the air quality of the agent, so it can be used for other uh, things as well. For example, for farms to detect the air right now in the farm, or for houses to secure the house in case of smoke or a fire inside, so it can alert the user of the bot. What's more, with the light sensor, we want to be able to make it detect if it is day or night. Also, if it is in a location that was dark and the light changed at this time without an obvious reason for the user to be notified. And generally, many sensors will be used for notification for a user, or for the user to be able to find well, to be able to see if there's something weird in the location of the bot, but also the bot to be able to see what is happening around it, and to adjust its personality and its memories, not memories, its current state at the time right now.
So this is all about the project. If someone has a question, let us know. We can answer anything. No? Okay.
We're aiming for a demo in the near future to be able to show the robot as a whole to be moving around to talk, but in a basic manner without. And so in around a month we want the basic demo, and then we'll move forward based on requests and what people prefer. I mean, to go towards, like, if they prefer to make it a person assistant or or like a security guard, or for farms and animals, or farms or fields, or generally anything else. It's meant to be built for anything.
Okay, how small robotics machine can be and how it costs to complete it. Okay, the cost is not too much. It's like, I don't know. Now I gave 200 euros probably, and it will be cheaper. We're testing this moment. So how small robotics machine can be? It's too early to answer that. I don't know. I make a test for now. But I think if someone use it for a farm or a field, because the field and surface of the field will be rough and it have to be a big size, I think. I will test it and I'll let you know.
About the future of robotics and after the AI, so all the robotics will be able to be more autonomous as from before, and a user won't really be needed to send the actions of the robot, but it will be able to decide by itself what it will be doing, making it easier for for people to use the robot for anything, actually. Also, there will be more use cases as well for the robots, and people that don't know programming or mechanics will be able to use them as well, thanks to the AI. I can share actually some references later today or tomorrow about AI robotics. And a good reference point is always, uh, well, actually, to learn about AI and robotics, Python is a must as a language because most AI models are built on Python. Then for models, you can use uh, Hugging Face and GitHub to find existing models that you can implement and use or train again, etc. And finally, for robotics, the Raspberry Pi forum has many information and that can help with that.